Welcome back to the Philco 90 restoration project. Now, since we last left off, I haven't done anything. And when we left off, I had just rebuilt, worked on this block, replaced one broken resistor. There was noise between stations, almost like motorboating kind of sound. Well, it's the next day, later in the evening. It's after 8. All my previous power-up checks were in the afternoon. The problem's gone magically. All I've done since then is check some resistor values. So, all right, we will continue on. Now, I checked all these resistors, and they are remarkably close to what they're supposed to be, within 10%, except for this one. So that was a 240, got replaced with a 270, because it's the closest I had on hand. That's a 240, that's supposed to be 240. That measures over 400 kilo ohms. So that should get replaced, and that goes right to the bias voltage. And I mentioned earlier about the biasing on these tubes could be off, which would definitely affect gain. So we'll be replacing that, but something else I wanted to do is we're going to restuff this block. Now this is the coupling cap between the first AF and the output tube. This is the previous cap we replaced, and this is one that had also been repaired long ago. Now these are not going to affect what the issue we're still trying to solve, which is why can't we get the volume to go down all the way. These are just interstage coupling caps. Not a whole lot of voltage across them. I'm actually a little surprised that they were leaky enough that they needed repair or replacing. But anyways, what I want to do before I do that is we're just going to clip this one out while the radio's on and playing and see what happens. So let's tune into a station so we got something nice and clear to listen to.
That means faster speeds for streaming. Oh my god!
All right,
Radio chatting?
let's cut it out.
Yes! Oh, too nice!
It actually got louder. Which makes me wonder, why did it get replaced? Unless whoever was working on it back in the day, just as a matter of course, because they had experience with this model, just went ahead and replaced those. I don't know, but I also said it was odd because it's across a cap, it's already in circuit. So, you know, it just occurred to me, maybe I'm looking at this the wrong way. Maybe that had nothing to do with repairing a leaky cap. Here, let me turn this off. Maybe it had to do with the frequency response. And this cap was fine and is still pretty much fine. And they tacked one on, which I believe is the same value, so they would have doubled the capacitance from 0.01 to 0.02. What would that do? I would imagine that would boost the lower frequencies. No, that's a 0.02. So they went from, originally it was a 0.01. This would have bumped it up to 0.03 microfarads. I'd forgotten about that. That back in the day, people would modify their radios to improve the frequency response. Like adding capacitance generally improves the low frequency response. So that's what that must have been about. Well, we're going to put it back to stock regardless. So I'm going to clean off those leads that were tacked on, and we're going to get this guy out, and we're going to restuff it. We're going to replace that resistor. I'll do a quick power up, but I don't expect rebuilding this block to have really any effect. Replacing that resistor may, though. And I want to move on to doing. You know what? We're going to stick with the plan and try to figure out the audio issues. So we're going to go after these other caps here. This 0.25, the ones that are marked 30, the 0.1, the 0.25. Time for another power up. I replaced this resistor, which is measuring around 340K. It should be 250K. And yeah, the resistor that's in there is a 2-watt. This in my hand is a 1-watt. Why are they so much smaller now? Because the materials they use now can withstand higher temperatures much better than the old stuff. Downside is, even with the full leads it's shorter, so I couldn't reach from one lug to the other lug. Deal with that later. They do sell this type, which is a PR02 made by Vichy in a 3-watt size, that are considerably larger, which means the leads extend further. So I may want to get my hands on some of those. I got a few, but not a 270K. Alright, I also restuffed that block. I suspect that won't have much effect. That was the .01 that had been bridged with a .02, making it a .03, we think, to increase the frequency response. I also snipped out another one of those caps that's in the block, this guy. 0.25, I put in a 0.22. A very convenient tie point. So it goes between these two resistors, and then the ground is RF bypassing, basically. Which leaves this one. And I checked out the circuit, and that is the cap that goes to the volume control. So again, it was a .01, and they put a .02 in parallel with it. So clipping that out will probably not do a whole lot other than change the frequency response a little bit. Alright, here we go. So this resistor goes to negative bias, and then to some resistor dividers to provide biasing for some of these tubes. That should have some effect. It was off by, I don't know, 30-some%, something like that. The tolerance on these things was so wide that it probably won't have a huge impact. If anything would have any impact, I expect it to be that guy.
Yes, Dan Evans will serve as chief operating officer of the venture. That's cool. At the cross.
Honestly, things don't seem to be a whole lot different.
And I'm asking you, God, to forgive me of that. И помните, что консультации не бывают рано, они бывают поздно. Звоните Иосифу сегодня. 847-520-7030. 847.
Okay, so we are going to keep on keeping on. Now, yes, I'm departing from the methodical approach because, well, I'm kind of at the point now where there's only a few big light blocks left to replace, and it's hard to say. I mean, I'll keep doing them one at a time. Oh, hey, let's turn it back on for a moment. Let's clip out this one while this set's live. So replacing that one inside, I expect when I clip this out it'll slightly alter the sound. I expect replacing it won't do much of anything. Okay. That one, let's see what the cap is that. Okay, that is cap 46, this guy. This one, it's not as obvious to me what it's for. I mean, it goes to the grid on the IF tube. On the other side, it goes to a resistor, to equal valued resistors going up to the detector. So that's probably part of the AVC. So initially I thought that this was the only part of the AVC which affects the grid bias on the RF tube. But in that related circuit, another resistor going to a cap going to a grid, that's also probably very likely to be part of the AVC circuit. So replacing that cap may improve the AVC action even more. I don't think it has to do with our sound leaking through, though. I still think it's going to be one or both of these metal boxes. That's why I'm saying at this point I think it's time to just fully replace those. So replacing this cap link up to the volume control, I don't think it's going to do much of anything. Rebuilding this block may improve the AVC. I think replacing the last couple caps in here will resolve our audio bleed through. Now, as I've been going through and rebuilding these blocks and getting familiar with the radio, I've noticed something. There are 3 basic functions for all of these paper caps. One is to provide bypass for voltage dividers. So for example, whenever we've got 2 resistors together that are dividing voltages down to provide screen voltages or grid bias voltages, there's always a cap. Those are bypass caps. It's to bypass RF to ground to get a nice stable DC for biasing the tube. We have another one over here, same deal. Couple resistors, dividing voltage down, bypass cap to ground. Another function is coupling. Coupling cap to this tube, coupling cap to this tube, coupling cap to that tube. Those 3 all seem to be fine. A couple of them they had doubled up, I presume to increase the low frequency response. And the final is the AVC function. We had one here, or have one here rather, for the RF tube, and we have one for the IF tube. That's it. There are other caps in here. They are all much smaller values. There are the adjustable ones for the alignment, and there are a few mica caps. There's one hiding down here, and another one hiding up here, and there might be 1 or 2 others. They tend to be pretty stable. Might be an issue with them. What are those used for? Well, there's one here right across the volume control. That's probably there to cut out high frequencies. In other words, the low pass filter, probably to take out some of the hiss and crackling that you might get with reception. We've got one over here that is for the detector. It's to filter the detected IF. So imagine you've got a modulated 175 kilocycles for the IF. You rectify that. Well, you've got now an audio signal with a bunch of bumps in it of 175 kilocycles. You want to filter that out, so you've got that. Now you don't need much of a capacitance to filter out that high frequency, but that is what the 110 is for. And Philco, for some reason, really like to use 110s. Not 100, not 120, but 110. I happen to come across a good stash of 125s. I've replaced many 110s with 125, and they work just fine. Notice there's another 110 down here. They must have cornered the supply on them or something like that, or gotten a good deal, because they use a lot of 110s. That is not a standard value. That must be that guy, and that's how they tend to look in these Philco radios. Yeah, they usually have a yellow and a blue dot on them, and they're squares. Those would be your 110s. We can check those later with a capacitance bridge. Seeing as the radio is working fairly well, they're probably fine. And that much larger one there, that would be the 250 for the volume control. Alright, so up next we're going to finish completely bypassing these 2. And then power the radio up again, see how things are doing. And then we'll do these final 2. And then we're going to go through and check resistors, replace any out of spec ones, then we're going to do an alignment. Seems pretty quiet. Huh. Now that's with the volume control all the way down. It should be quiet, but we shouldn't hear anything. Hey,
Here comes the note.
We have a functioning volume control of sorts. Now it is very, very little range, and I'm hoping that's because it's a linear taper rather than logarithmic. So what happens is when it's all the way down, we basically have nothing or very, very little volume. Turn it just a hair. Gets louder, a little bit more. So about 5% of the rotation goes from almost nothing to booming. And from there on up, it just stays pretty loud. Cool.
Time to step inside the base runner and make the throw.
Now let's.
Caught it, turned and fired right off of the shoulder of
Jupiter, are you trying to big your China again?
There's no reason for that. And I know
Can you pause for a minute?
Playing first base a lot this year. He's a natural second baseman. But we've seen multiple times this year where at first base.
All right, let's get a comfortable volume and then go through a number of stations and see if they're about the same volume. There's AM 1000.
Corner men are in. Middle men are back. Now Castro in third will back up.
Good volume level. 890 is another local station. About the same volume. Now here's 820. That's the one that came in really loud earlier. It's later at night now. And one of my viewers confirmed that during the day, they broadcast from a location very near me. At night, or after the sun goes down, they broadcast much, much further away. Like 100 miles away or 50 miles away, something like that. So it's not surprising that it's weak. I don't think that's anything to do with this radio. It's weaker on every radio I've got. 780, about the same volume as 890.
I know you put off going to that dentist. This is John Williams.
About the same volume. Excellent. About the same volume. Those are all the major stations around here. 670, 720, 780, 890, 1000. The rest of them are all a bit weaker. So I wouldn't be surprised, like 560. They just don't come in that well. Now, one of my viewers left a great comment that I should show the actual AVC voltage while tuning around the dial. And luckily I got that comment before I posted this latest installment, so let's take a look. Right now I have got my voltmeter at the junction of that 0.49 meg and 0.05 microfarad cap number 46. And that is going through a coil into the grid of the IF tube. So this would be the IF AVC voltage. So when we've got nothing, we're in between stations, it's about minus 0.3 volts, which isn't much. It's not very negative. So it's the more negative it is, the more the tube is cut off. So this is, well, you'll see what happens when I tune to a station. The voltage gets more negative. Now that's not a very powerful station. Let's get to a stronger station. So nothing, down to minus 0.2, or up to minus 0.27, I guess you could say. Stronger station, minus 8.5, 8.9, or minus 9. Get to about minus 1 volt. What does that mean? The grid is now more negative. That means the tube is more turned off, I guess you could say, which means it has less gain. Lower station, it's less negative, or you could think of it's more positive, which means the tube is more turned on, more gain. Get to a station, it's more and more negative. Seems to top out at about minus 1 volt or so. Let's get to the strongest stations around here. Minus 1.1. So that's how the AVC works. Now let's check the grid on the RF tube and see how that AVC action is, which should be pretty darn similar. Alright, now voltmeter on that point. So that would be the AVC voltage for the RF front end amplifier. So at a quiet point, we've got about minus 0.6 volts.
Get
to a station. More negative. Minus 1.2, 1.3. Quiet point. About minus 0.6. Load station. Minus 1.6. Oh, minus 2. So that's cool. So it works as advertised. It changes the bias point on the tubes and it changes their gain. Now, something of interest, you probably have all seen radios that have eye tubes. That's the voltage that controls the opening and closing of the eye on an eye tube. Philco used a shadow meter on several radios. I've shown some in the past, and I will be in an upcoming Model 118 video, in which case that voltage controls a vane, sort of, which does a similar thing to an eye tube where it opens and closes an illuminated translucent piece of plastic. But that's the deal. That is a great signal strength indicator, as well as controls the bias on the tube, so you get pretty consistent volume as you tune around the dial, and that is how AVC works. Now that we've got this box completely out of the circuit, let's remove it. 1/4 inch nuts, of course, like everything else, because then we get access to the 3 mounting screws for the tuning cap, and we are going to replace those rock hard grommets. Interesting thing about these boxes, at least the way it was mounted in this one, you only have to take out 1 screw completely, the other you can leave in place and it slides out. Eventually we will rebuild this. It's bulged out a bit. You can get a good look at it. It's a tin box, maybe cadmium plated. It's a bit worn off. So to get these open, well, you pry open these tabs and then the whole inside slide out. Cardboard cover on either end can be reused. Stick new caps inside, run new wires out. Pretty easy. Here, I'll go ahead and pop this open. Remember when I was talking about tools, I mentioned one thing that can be handy are these snub nose pliers. They're good for things like this. Take it easy on these tabs because we want to reuse them. We don't want to bust them off with metal fatigue. These are handy because you can bend the metal and flatten it without leaving any marks, really. Because there are no serrations on these jaws, they're just flat. Alright, if all goes well, ta-da, it's just that easy. And that little wire there is ground. It's just soldered on to the top of the box. And that's that. And then we can just remove this and we can reuse it if we want. And you can see the mess that's inside. This just goes in the garbage. And the new caps, of course, are going to be much smaller. There'll be a few caps about this size inside there, obviously way bigger than they need to be. So we'll get our 3 caps, we'll gather up the ground leads, we'll connect it to the box. The other 3 we'll attach extension wires on, we'll put them inside, and we can fill this up with something, bubble wrap, paper towels, something like that. We don't need to fill the whole thing up with tar or wax or anything like that. That would be overkill. Alright, anyways. That's assuming one wanted to restuff that box at all. Obviously you don't have to. You can just mount the caps down around here like I have them now. That is entirely up to you. Alright, so these are what we want to replace. The reason I want to do that now too is that I got an order in to Renovated Radios while they're still open. He was out of stock on some of the other stuff that I wanted, but he's just trying to sell off his inventory and then shut down the business. And here's some of the great things he made. And so when I left that video, I talked about him shutting down his shop, and a number of you chimed in about, well, 3D printing. Well, you can't really 3D print nice soft rubber parts. So he went to a lot of effort, not just to get the dimensions right, but the hardness of the rubber material. There have been some folks apparently who have expressed interest in taking over some or all of his stuff, his molds, his inventory, hopefully his knowledge. So we'll see. Other places, there's Radio Days, Antique Electronic Supply, just something out of the world. Alright, so these things, these mounts, the way these work is sheet metal screw, washer, then there's a metal collar, and there's a rubber grommet, which is broken in half because the old one is, it's natural rubber. So I was reading up about rubber. There's the same with the rubber in these wires. To process it, they add some sulfur to it. And apparently if you use a little bit too much sulfur or not enough, it degrades more rapidly over time. I guess if you got it just right, and I think if the environmental conditions are just right, it can actually stay flexible for a very long time. There's the collar. Now here's a tricky bit. The other bit is on top. What we're going to do is we're going to take all three of these off, but it's still attached with wires and stuff. It's not completely out. And we need to shove this. Notice it's two pieces, and there's an inner part that's thinner. We got to shove that through the hole, such that half is above and half is below. Notice they aren't exactly the same thickness. One part's a little bit thicker, one thinner. I'm not sure what goes where. But eyeballing it, compared to the old ones, it looks like the thicker part, which isn't much thicker, but it is slightly thicker. That should be underneath. So, let's see. Maybe if I loosen these up, I can do them one at a time while leaving enough tension on this that the whole tuning assembly doesn't fall off. See, I gotta get the remains of the old rubber out of there. Here's a look from the top side. So here is the tuning assembly. It's very loose right now. And that, if I shine some light from below. See that light's coming through, that's where the rubber mount needs to go. And then the end of that screw is actually going into this. It's going right through a hole in the chassis and screwing into this top capacitor part. And then it kind of floats on those rubber mounts. So we need to get that out and get a new one in. Let's use our Bakelite block poker and see if we can just gingerly poke this. I should mention too, there's a very fragile dial scale on the front of this radio. You don't want to break that. Yeah, there are reproductions available for now. So Renovated Radios did a lot of reproduction rubber parts and some knobs, casted knobs. Radio Days, on the other hand, does a lot more with reproduction. Oh man, that's tough to get out. It's hung up under there. Reproduction dial scales and decals, graphics, in other words. I got that top piece out, but now it's kind of wedged in between the two, kind of fell down inside of there. I'm going to go ahead and take the other screws out all the way and poke out all the bits, and I'll just have to kind of hold up this capacitor assembly while I'm doing that. Yeah, okay. I think that's good. Put her down. See how it sits now. Yeah, that's pretty good. It should have some play, but not to be too crazy. The final thing will be to see how this hole lines up through the center of the cabinet. That's the other problem. If these disintegrate, this will drop down. It'll be rubbing the bottom of the cabinet. Here's a little close-up of the dial scale I was talking about. You do not want to crack that if you can possibly avoid it. And here's the dirty chassis. These are aluminum. You can polish these up super bright if one so desired. The rest is plated steel. See, in a few places we got some corrosion. We'll take care of that later. I'm not going to go crazy with this. I don't think I'm going to bother painting the transformer or anything. But I'll blow the dust off. And brush debris off and whatnot. Just make it look a little bit nicer. And we will lube up this tuner. It's got a few bearing points here and there. So it's kind of interesting. You might think, oh, this shaft just goes right into the tuning action. No, it's offset. They use this kind of concentric mechanism to give you a reduction ratio. So this rotates this outer ring, then drives that. So it's kind of like having two gears of different diameters, but really it's just a wheel riding on the outside of an inner part. That makes sense. I think there are some bearings down there, but or at least there's certainly some points we can clean and grease. There's probably a single ball bearing in the back.